All right, so now that we've gone through significant figures, we need to talk about how we deal with significant figures when we do calculations. Because there'll be a lot of times when we take measurements and have to use those in calculations. Remember, significant figures are a measure of precision. And precision is based on the instrument we use to take the measurement. Okay, so when we do calculations, the calculation shouldn't shift the precision. We can't get better precision by doing math on them, and we can't make it worse. So we need to look at how to deal with significant figures when we do calculations. So, as I just said, precision or significant figures is a measure of where the uncertainty occurs or where the error starts. So we're going to have rules to use when we do calculations. Okay. What we're going to look at in this section is simply multiplication and division and addition and subtraction. There are a couple other calculations we may run into later on in the semester that we'll have to deal with. One would be calculating pH for dealing with acids and bases, but we'll deal with that then. Here we are going to just deal with multiplication and division and addition and subtraction. And the nice thing is that we have the same rule for multiplication and division. So we have one rule for that, and then we have one rule for addition and subtraction, and that's it. So, when we do multiplication and division, what we do is look at the numbers that we start with, the things that we're going to multiply or divide, or some combination of. And we look at those, and whichever one has the least number of significant figures, our answer should have that number of significant figures. If that didn't make sense, let's do a couple of examples and see what I mean. So we've got 6.502 times 0.53. Okay, if I do that math, grabbing my calculator here, 6.502 times 0.53, I get 3.44606. That's a different blue we're using this time. Now, looking at the numbers we started with. The first number has 4 significant figures, 4 SF. Our second number has 2, right? That 0 doesn't count because that's a leading 0. That starts the number. That doesn't count as a significant figure. The 5 and the 3 do. So 2 significant figures. That means my answer should have 2 significant figures. So starting from the left, 1, 2. The 3 and the 4 are significant. And that's it. The number after that, we're going to look at. So, if the number after the last significant figure is 5 or greater, we're going to round that last significant figure up. Okay? In this case, we have 3.4. The next number is a 4. So that means that 4 that's a significant figure, we're not going to round it up because the number after it is less than 5. So my answer with correct number of significant figures is 3.4. Okay? Let's do another one. 120,000 divided by 5.16. So 112,000 divided by 5.16. I get 23,255.8. Okay, same thing. It's a division, so we count the number of significant figures in our the numbers we used. So 1, 2, trailing zeros don't count unless there's a decimal, and there's not a decimal. So that 120,000 has 2 significant figures. 5.16 has 3 significant figures. Those are all non-zeros. So 2 and 3, my answer should have 2 significant figures. So the 2 and the 3, we check the number after it. It's a 2, so we don't round that 3 up. Here's the thing, though. The value of this number is about 23,000. Okay, so we can't just write 23 as the answer. because that's a factor of 1,000 wrong. Okay, so what we do when we only want two significant figures, but we want the number to be larger than just 23, we want it to be 23,000, we add zeros until we get to the decimal, or where the decimal would be. So 23,000 still has the same scale, it's the same size as the number we had, except now it only has two significant figures because those trailing zeros don't count, right? So make sure when you're doing calculations that you're not just dropping all the significant figures if the number is bigger than what you just do significant figures for, right? So if I just do significant figures, it would be 23. But that's not right because the answer is like 23,255. So I got to make sure the scale of the number is the same, but I only use two significant figures. So I get my two significant figures, 2 and 3, and add zeros to make the number the same scale as the answer was. So I add zeros till I get to the decimal. All right, next one. I got a bunch of multiplication, but they're all they follow the same rule, so I can do all the multiplication and then I can do it all at once and get an answer. And then I'll deal with significant figures. Okay, so 4.63 times 0.00023 times 8,295 times 30.7. It equals 271.184. Okay, so following our rule, let's figure out how many significant figures in each of the numbers that we started with. So 4.63 has 3, 0.00023, remember leading zeros don't count, so this one has just 2. 8,295 has 4. 30.7 has 3 significant figures. So the least number we have is 2, so my answer should have 2 significant figures. The 2 and the 7 are significant. The number after the 7 is 1, so it's less than 5, so we're not going to round 7 up, we're going to leave it the way it is. So my significant figures are 2 and 7, but the number should be, my answer was 270, not 27. So, my answer was 271, right? But I don't want that last number significant, so I'm going to do 270. Okay, that gives me two significant figures, 2 and 7, but it still has the same scale. It's 270, right? All right, last one. Again, we have a mixture of multiplication and division, so we can do the calculation and then figure out significant figures. 87.4 times 9.053 divided by 53. 14.929. Okay. Look at the significant figures in our initial numbers. 3 for 87.4, 4 for 9.053, and 2 for 53. So my answer should have 1, 2. The number after the 4 is a 9, so we're going to round that 4 up to 5. So my answer would be 15. All right, so that's how we're going to deal with significant figures when we do multiplication and division. Let's figure out the rule for addition and subtraction. Sig figs in addition and subtraction. Okay, so when we're performing addition and subtraction, we're going to line up the decimal for each of the values. So we're going to do this vertically. We're going to line up the decimal and determine which of our values where we run out of significant figures first. Okay, so let me do it and you'll see what I mean. So my examples, 2.50 plus 28.407 plus 128.3. So I'm going to write these vertically, 2.50, 28.407, 28.407, and 128.3. So what I've done is lined up the decimals. Now I'm going to go left to right. And I can see that my last significant figure in 2.50 is at 0. My last significant figure in 28.407 is the 7. And my last significant figure in 128.3 is that the 3. So if I'm going left to right, I can see that 3 is where I'm going to run out of significant figures first, in the 10th position. So what I do is draw a little line down, showing that I've got to stop my significant figures one place after the decimal. So if I do this calculation, 2.50 plus 28.407 plus 128.3, right, because I'm adding all these plus, I get 159.207. But from where our significant figures run out, I can see that I need to stop my answer one number after the decimal. So I look at the second number after the decimal, which is a 0, which means I'm not going to round the 2 up. I'm going to leave it as a 2. So my correct answer would be 159.2. So this would be 159.2. Okay, let's do the next one. Again, lining up where the decimal is. So 9,500, 230, 17,000. Okay, so my decimal would all be on the right there. But I don't get to the decimal. So what I'm going to do is mark where my last significant figure is. So 9,500, the 5 would be the last one. 230, the 3 would be it. And 17,000, the 7 would be it. So if I'm looking from left to right, that 7 is where I run out of significant figures first. So at the 1,000 position. So that means I'm going to draw a little line down there. So when I'm at the 1,000 position, that's where my last significant figure is going to be. So 9,500 plus 230. Oh, nope, it's minus 230, right? So it's minus 230 plus 17,000. So let's do that again. So 9,500 minus 230 plus 17,000. I get 26,270. Okay, my decimal is after the 0, but there's not a decimal in the number. My last significant figure, or the significant figure where I have to stop, is the 6. Right? We said we run out of significant figures right there when I'm going left to right. So I'm going to stop my significant figures there. And we'll look at the number after it. It's a 2. So I don't have to round the 6 up. So I'm going to get 26. And then remember, this is 26,000 something. So I'm going to add zeros until I get to where the decimal would be. So my answer is going to be 26,000. Like that. And that's it. So that's how we deal with addition and subtraction. What happens if we have mixed calculations? Sorry, my throat's a little dry. If we have mixed calculations, we have to do each one kind of separately because there's different rules. So we do the calculation, follow the rule for that calculation, and then do the next. We don't round until the end. Alright, so let me show you how we're going to do this. So 1.65 minus 0.928. So 1.65 minus 0.928. I get 0.722. Okay, so if I'm following my rules for addition and subtraction, I can see that this number runs out of seven figures after 2 decimals, and this one runs out after 3. So if I was going to put an answer right now, it should only have 2 decimals in it, because following the rule of addition and subtraction. I'm not going to round that yet. I'm going to understand that my significant figure should end at 0.72, and that's it. Okay. Now I'm going to multiply that by 71.83. So basically now I've got 71.83 times 0.722. I'm going to mark that middle 2 as that's where my significant figure should end. So 71.83 times 0.722. I get 51.8613 is my answer. All right, so for multiplication and division, our answer should have the least number of significant figures, the number of significant figures that our initial calculation, the least number that our initial calculation had. So 71.83 has 4 significant figures. 0.722, we marked where our significant figure should end, so our significant figures in that number should just be 7 and 2. So that only has 2 significant figures, so my answer should only have 2. 51.8613, so 5 and 1. The number after that is 8, so I'm going to round the 1 up to 2. So my answer is 52. 2 significant figures. Good. All right, next one. Following our orders of operation, we need to do multiplication first before we subtract. So 2.6 times 0.732, I get 1.9032. Following our rules of multiplication and division, we can see 2.6 has 2 significant figures, 0.732 has 3 significant figures. So my answer, if I was to stop here, would have 2 significant figures, right? It would be 1.9. But I'm not going to round yet. I don't want to round until the end. But I need to know that the significant figures runs out at the 9 there. So now I've got 8.165 minus 1.9032. I'm going to mark the 9 because that's where I should have my number ended. So 8.165 minus, oops, what did I do here? 8.165 minus 1.9032. I get 6.2618. Okay. Following our rules for addition and subtraction, so for the 8.165, my last significant figure is 3 numbers after the decimal. For my 1.9032, we already said that I should stop at 1 number after the decimal. That means my answer should stop 1 number after the decimal. So looking at 6.2, I should stop there. The next number is a 6, so I'm going to round the 2 to a 3. So my answer should be 6.3. Okay? All right. So here's some practice. Again, pause this, do the problems, and then come back and check to see if you got them right. All right. So hopefully you've run through these. Let's make sure we're good. So the first one is a division. So division says our answer should have the the same number as the least number that we have to start. So 45 has, two significant figures. 2.509 has 4. So when we do the calculation, our answer should have 2. So 45 divided by 2.509, it's 17.935. But I only need 2 significant figures, so 1 and the 7. I'm going to check the number after the 7, and it's 5 or greater, so that means I'm going to round the 7 up. So I'm going to have 18 would be my answer. 2 significant figures. Okay? Next one. Oh, scientific notation. But remember, in scientific notation, the number of numbers we have in the decimal part is how many significant figures there are. So this one has 2, and this one has 3. Okay. If you haven't done significant figures on your calculator, or if you haven't done scientific notation on your calculator, I've got a little video about that, so check that out. So make sure you're using your calculator properly with scientific notation. So when we put this in, 2.5 e to the 6 times 8.91 5. So I get 1.782. That's it. Okay? So 2 significant figures here, 3 here. So 1 and the 7 are significant. Anything after that is not. Checking the number after the 7, it's an 8. So I should round the 7 up. So I get 1.8 as my answer. Okay? Next one is addition. Let's do the math. 45.2 plus 6.982 plus 6.923 plus 32.08. I get 84.203. Okay. There's one number after the decimal here. There's 3 here, and there's 2 here. Because it's addition or subtraction, I should stop with the least number after the decimal. In this case, this is 1 after the decimal. This is 3, this is 2. So my answer should only have 1 after the decimal. So 84.2. The number after the 2 is a 0, so we're just going to leave it as 84.2. All right? The next one's a mixture of addition and subtraction. So let's do the calculation. 12500, 3000. We're going to subtract those. And then we're going to add 700. We're going to get 10,200. Okay. So looking at where I run out of significant figures. This runs out at the hundredths position. This runs out at the thousand position. And this runs out at the hundredth position. So wherever the highest position it runs out, that's where our answer needs to be. So that would be the thousands position. So that means the thousands position here is where I should stop my significant figures. Okay, so after the 0 is a 2, so I'm going to round the 0 down. So I'm just going to leave it as 0. So I get 10,000. Theoretically, that 0 is significant. And when I write it as 10,000, it doesn't look significant. Right? It looks like there's only one significant figure there, but there should be 2. The 10,000th position and the 1000th position are both significant. So it should look like 2 significant figures. When I write 10,000, it only looks like 1, because trailing zeros aren't significant unless there's a decimal. Now I could put a decimal there, but that would make it look like 5. So what I should do is write this in scientific notation. 1.0 times 10. So I got to shift the decimal 1, 2, 3, 4 to get it right there. So I can write it as 1.0 times 10 to the 4th. Right? Because I can show 2 significant figures there, and it's still 10,000 because I take 1.0 multiply by 10 4 times, and that gives me 10,000. All right, last one. 52.8 minus 46.92. That's in the parentheses, so that's what we have to do first. Oops. 52.8, 46.92, 5.88. Okay, so we get 5.88 divided by 6.242. Okay, figure out significant figures from our subtraction. So I have one number after the decimal for 52.88. I have 2 for 46.92. So my answer should only have 1 after the decimal, 5.8. I'm going to leave the other 8 there because I'm not done with my calculation, but I'm going to mark that I'm going to know that that number should only have 2 significant figures in it. I'm going to now divide by 6.242, and I'm going to get 0.94201. Okay. For multiplication division, we look at how many significant figures we have in both of our calculated numbers, and whichever one has the least, that's what our answer should be. So we know that our 5.88 should stop at 5.8, so that has 2 significant figures. The 6.242 has 4, so my answer should only have 2. The 0 does not count, so the 9 and the 4 count. So those are my 2 significant figures. The number after the 4 is a 2, so we're going to not round up, we're going to round down. So 0.94 would be my answer, 2 significant figures. Right? I know this is probably the first time you've seen this. If you're not quite understanding this, please come and see me in office hours or drop me an email, and I'll try to clear things up for you.